Alright, field effective transistors. Introduction field effect transistors is a three-terminal device used with a variety of applications matched to a large extent with a bias junction transistor and joint field effect transistors. Is a voltage control of the device. The field effect transistor called the ampere ID or will be function voltage with voltage GS applied with the input of the circuit. Field effect transistor unipolar device depending solely on the other election negative channel or hole or positive channel conduction. Term field effect with the name is deserves some of the explanation. All familiarity with a permanent magnet drawing metal filings itself with the need of the actual contact with the magnet field over the permanent magnet envelope of the filings attracts them to the metal with along with the shortest path provided with a magnetic flux line with the field effect transistor and effect field established by charge present which control the conduction path of the output circuit without need of the direct contact between the controlling controlled quantities. Our figure 1 shows a voltage-controlled amplifier. You have your ampere diode. Comparison some of the general characteristics of the bias junction transistor field effect transistors. One of the most important characteristics of field effect transistors is its high input impedancy. The variation output current typical with a greater deal with a bias junction transistor than a field effect transistor from SIM change with the applied voltage. Field effect transistors are more temperature stable within bias junction transistors. Field effect transistors are used similar to the bias junction transistors, making some particular use of the integrated circuit chips. Construction characteristics of field effect transistors, however, can make more sensitive to handling basic junction transistors. Three types of field effective transistors: junction field effect transistor, metal oxide semiconductor field effective transistor, MOSFET. Metal semiconductor field effect transistors, or MOSFET. The metal oxide semiconductor field effective transistors is further breaking down the depletion enhancement type. The metal oxide semiconductor field effect transistors have become one of the more important devices used in design, construction, and integrated circuit digital computers as thermal stability, other general characteristics extremely popular computer circuit design. Construction characteristics: joint field effective transistor, three-terminal device, one terminal capable of controlling the current between the other two. The majority of the part of the structure negative type of material forms a channel between the embedded layer of the positive type material. The absence applied with potential. Joint field effective transistors has two positive and negative junctions with no bias condition. The result of the depletion region at each junction is shown in Figure 2 that resemble the same region of the diode under no bias condition. Figure 2 shows the joint field effective transistor, so the positive and negative and the negative channel of the ohmic contacts, your source, the gate, depletion region, and depletion region of positive and negatives, and that is your field effective, joint field effective transistor. Alright, V voltage gain is equal to 0 voltage times voltage DS. Positive voltage DS is applied with the channel of the gate is directly to the established voltage GS with U with the under-conditioned flow of the charge relative to the uninhibited to the low resistance of the negative channel with the draining source for the depletion region with a wide near the top of the bowl for the type of the current input drain will establish voltage level of the channel will indicate with the figure the result of the upper region of the positive type of material with a reverse bias by output voltage drain and the source is increased to 0 volts. Few volts current will increase with the determined lowest plot with the ampere drain and voltage drain source. As voltage drain source increase approaches with the lever preferred to its voltage P. The depletion region will be widened, causing a noticeable reduction in the channel width with the reduce the path of conduction, causing the resistance to increase. The more horizontal of the curve, the higher the resistance, suggesting the resistance of the approach to the infinite ohms polarizing region. If voltage drains and source is increased to the level which it appears to be the two depletion region will touch, and the condition referred to as the pinch-off will result. And it shows another figure. Voltage drain and source is increased by voltage P. Region that close encounter of the two depletion regions increased length of the line with the channel level of the ampere to drain, resulting essentially for the same assessment, therefore the voltage drain source 7. The voltage P, the junction field, joint field effective transistor, joint field effect transistor character of the current source, as shown in Figure 5. Currents as fixed as ampere drain source. Saturation voltage drain source is determined by the applied load. Choice for the notation IDSS is derived from the fact that the drain source current with a short circuit connection gate. So the ampere drainage source short circuit maximum drain current of the joint field effective transistor is defined with the condition as V joint VGS equals 0 and V joint drain source is greater than voltage P absolute. Voltage GS is less than 0 volt voltage from the gate source over the VGS, controlling the voltage of the joint field effective transistor. The curves of the ampere drain versus voltage drain source of the various levels of voltage gain source. It's going to be developed by the joint field effective transistor. The new N channel can control the value voltage of the voltage gain source of the main, but the more negative of the voltage gain source of the 0 volt level. The effective applied negative volt bias the voltage gain source to establish the depletion region similar to over the obtained by the voltage gain source of 0 volt must be lowered level of the voltage drain source. Therefore, the result applying the negative base of the gate is the reach of the saturation level of the lower level of the voltage drain source shown in Figure 6. Voltage gain source of the negative 1 volt resulting in saturation level of the amperage drain over the reduced. In fact, will continue with the decrease of the voltage gain source made more and more negative effective with the very voltage gain source. When the voltage gain source equals negative voltage power will be sufficient negative to establish saturation level the essential for the 0 microamps for all of the particular improved purpose of devices that have been turned off. In summary, the level of the voltage gain source will result with the ampere diode 0 milliamps defined as voltage gain source, voltage power, negative voltage, the negative channel devices, positive voltage P channel joint effective transistors. Transfer characteristics, derivation, the base bias joint transfer of the transistor, the bipolar joint transfer of the output and output current, inputting control current, and or related to better, which we're going to consider the concept of the analysis performed in operation. So you have the ampere current is equal to the frequency of the ampere base equal to the beta of the ampere base to minus 1 square term and equation result of the nonlinear relation for the N, such as ampere drain and voltage gain for the producing curve of the exponential decreasing magnitude of voltage gain source. Square term equation result of the nonlinear relationship of the ampere drain with the voltage gain source, drawing the curve of the growth of the exponentially decreasing magnitude of voltage gain source. The transfer the characteristic of the Scully's equation unaffected by the network which device is employed. Depletion of the type of the MOSFET or metal oxide field effective transistors. Further broken down, depletion type of the enhancement. The term depletion enhancement defined with the basic mode of operation. The name of the metal oxides field effect of transfer stands for metal oxide semiconductor field effective transfer. Or basic construction for the N channel with the depletion type of the MOSFET with the provided with the slab of the P type of the material formed from the silicon base referred to the substrate of the foundation on which the device is constructed. In some cases, the substrate with an internationally connected to the source terminal with the gate is also connected with a metal contact strip that remains insulated from the negative channel by a very silicon dioxide layer. Silicon dioxide layer is the type of the insulator referred to as the dielectric, which sets up the opposing as indicated by prefix electrical fields with the dielectric when exposed to externally applied field. Base of the operation of the gate source voltage set at 0 volt. Voltage of the direct connection of one terminal over the other with the voltage of the DD applied with the drainage source to the terminal. The result of the attraction of the free electron of the negative channel with the post voltage to the drain. Result of the current similar voltage of the channel with the joint field of the effective transistor. In fact, the resulting current over the voltage gate source, 0 voltage labeled as ampere drain set source. voltage gate source is negative voltage with a negative 1, negative potential with the gate will attend with the pressure electron with the positive type of the substrate with a likely charge repel, track over the positive type of the substrate, opposite charges attract. Depending on the magnitude of the negative bias of the voltage gate source, the level of the recombination between electrons will occur with a reduced number of free electrons negative channel with available conduction. There are more negative bias, however, than the rate of recombination. These resulting level of the drain current is therefore reduced, increase the negative bias of the voltage gate source. Enhancement type of the MOSFET. The characteristics of enhancement of MOSFET are quite different. The depletion type of the basic construction slab of the positive type material with the form of the silicone base, again referred to as substrate as with the depletion type. MOSFET is substrate with sometimes internally connected to the source terminal, where the other cases fourth lead labeled SS is made available. External control potential level of source and drain terminals are again connected through metallic contacts in negative dope regions. By note, with the absence of the channel between the two negative dope regions, the preliminary difference between the construction of the depletion type of the enhancement MOSFET absence channel construction component of the device, and in summary, the area's construction of the enhancement of the type of the metal oxide field effective transistor, but quite similar to that of the depletion type of the metal oxide field effect transistor, except for the absence of the channel between the drain and source types. So we have the metal contacts, negative dope region, no channel, positive type, substrate, sources, and drain, and gain, and gate. Basic operation voltage gain gate source is set up with a 0 volt with the voltage supply between the drain and the source of the device. The figure absence with the negative channel, the generous number of free carrier of the result of the current effective is 0 amp. Quite different. The depletion rate type of the MOSFET with a joint effective transistor, where the amper drain with the amper drain source source S is not sufficient to have the large accumulation of the carriers of the electron drain source due to the negative dope region of the path fail that exists between the two. The voltage drain source, some positive voltage gate source with 0 volt terminal of the SS source directly connected to the source, and in fact, with the reverse bias, with the positive and negative junctions have the negative doped region. Positive substrate to oppose significant flow of the drain and source. The level of the voltage gate and source result of the inefficient increase of the drain current of the curve of the threshold voltage of the gain symbol of voltage T is the voltage threshold of the open specification sheet. If referred to as voltage gain threshold, although voltage threshold is less unwieldy, will be used in analysis to follow the sensor channel with a non-existent voltage gate source 0 volt enhanced by application of the positive gate to source voltage. The type of the metal oxide field effective transistor called the enhancement type of metal oxide field effective transistor. Field effective transistor biasing. Field effective transistor relation between the input-output quantity of the nonlinear due to the square term of the Shockley's equation. Linear relation with straight lines plotted with a graph of one various variable variate versus the other, with a nonlinear function result of the curve of the tame with a transfer of the characteristic joint effective transistor with a nonlinear relationship to the amper drainage voltage gate source. Complicated mathematical approach with a DC analysis field effective transistor configuration. Graphical approach with many limits may limit similar solution with the 10th place accuracy with a quicker method with the field effective transistor amplifiers. Since graphical approach is generally most popularly analyzed with the chapter that will have graphic solutions rather than mathematical solutions. Fixed base configuration, simple basing arrangement with a negative channel of joint field effective transistors appears in figure 1, referred to as fixed bias configuration. Figure 1 shows the fixed bias configuration. From DC, the voltage RG, resistance gain, resistant gate, amper gate, resistor gate equals amper gate is 0 amps. Factor with the negative terminal battery with the negative directly with the defective positive with the voltage gate source clearly reveals the polarity of voltage gate source directly opposite of the voltage gate gain. Apply Kirchhoff with the voltage of the clockwise direction and result. Since VG is fixed, the DC supply voltage G gate source is fixed in magnitude result of the direction of fixed bias configuration. Drain source of the output section is determined by applying with the Kirchhoff with the voltage laws. Self-bias configuration. Self-bias configuration eliminates the need for the two DC supply of controlling the gate source of voltage determined with the voltage drop of the resistor. Introduce source leg with a configuration DC and analysis capacitor can also be replaced with the open circuit with a resistor with a row resistor gate and replace with a short circuit equivalency. Ampere gate is 0 amps. Current with a result resistor source with the ampere source. Ampere source with ampere diode ampere drain voltage resistor source equals ampere drain diode resistor source. Ampere drain resistor source voltage gate source equal to negative ampere drain times resistor source voltage gate source function output ampere drain not fixed magnitude accord with a fixed bias configuration voltage divider biasing. Basic construction is exactly the same with the DC analysis of each of the quite different with the ampere gain with a 0 amplified field effective transistor amplification magnitude ampere base common emitter with a bipolar joint transistor amplifiers can affect with the DC level the current voltage age of both the input output circuit with both the ampere beta ampere base provides a link between the input output circuit of the bias joint in transistor voltage dividers configuration such as voltage gate source does the same as a field effective transition configuration. Since ampere gate is 0 with the Kirchhoff current required with the ampere resistor 1 equal to ampere resistor 2 with the theory of the equivalent circuit appears to the left of the figure that we use to find the level of the voltage gain. Voltage G equals the voltage curve of the resistor 2 used as the voltage divider. Rules as follows. Applies Kirchhoff voltage law. Alright, feedback over the amplifiers, oscillators. Feedback implies transfer energy output system to its input with a portion hold the output signal amplifier feedback superimpose with the input signal performance amplifier change significantly. Then the amplifier is said to be feedback amplified. Negative inverse degenerated feedback signal diminishes magnitude of the input signal. But with the directive regenerated feedback signal enhances the magnitude of the input signal. Negative inverse degenerated feedback shows the input signal positive going to voltage input voltage output the amplifier going to the feedback amplifier. Above the input signal amplified A and the difference input of the voltage source of the voltage signal feedback circuit contain positive elements that resistor inductor capacitors active elements like transistor transfer gain of feedback voltage input is equal to amperes times voltage input over the voltage input voltage output over the voltage input gain with a feedback open loop again. Voltage frequency or voltage feedback is known as feedback fraction, feedback ratio, reverse transfer ratio, reverse free transmission factor. Voltage input equals value saturation, voltage feedback, positive sign, positive feedback, and then we get a couple more equations. Ampere feedback is equal to voltage output over voltage saturation time equal to A amperes over 1 times amperes. So the beta is gain with the feedback closed loop gain. The quantity of the A beta is open loop gain. Feedback factor return ratio loops and transmission. Feedback and truth for the amplifier are usually expressed in decibels by the relationship, and then show the feedback decibel in log form. Negative feedback of the F is negative, and positive feedback F is positive. Feedback amplifiers. Feedback amplifiers topology. Depending on the input mixer output sample configuration, we have 4 feedback topology: voltage series, voltage shunt, current series, current shunt. Effective negative feedback. Number of improvements are obtained with negative feedback. Better established voltage gain, higher input impedance, lower output impedance, improved frequency response, reduced noise, more linear operation. Post-directive regenerative feedback. Positive feedback input signal amplifier with gain A is the addition of the input signal, Vs, and feedback signal. Oscillator operation. The use of the positive feedback for the result of the feedback amplifier closed loop again, and your addition At a tone frequency greater than 1 satisfied with the phase of the condition, result of the operation oscillator of the switch amplifier input with the no oscillation occurs. Zero fictitious if the voltage input with the amplifier input voltage output equals amperes voltage input and voltage input amperes beta voltage input. The circuits of the base amplifier feedback network provided with the alpha antidote beta with the correct with the magnitude favor the voltage frequency with the man be equal to the voltage input when the switch is closed with the fictitious voltage input with its removed the circuit will continue operating in since the feedback voltage is sufficient to drive the amplifier resulting proper input voltage sustain the loop operation output waveform still exists as the switch is closed with the condition amper beta is 1 met. This is known as the Barkhausen criterion for oscillation. Operator amplifier. With the operation amplifier direct coupled to high gain negative feedback amplifier is nothing more than a differential amplifier difference between the 2 points. Point and positive input acting point voltage 2, negative acting input voltage 1, voltage output general circuit diagram of an operational amplifier. The term is marked is inverting to negative is the term minus is called inverting terminal, meaning that the signals applied there will appear in a phase inverted to the output, while the terminal marked positive we call the non-inverting terminal, meaning that the signal applied here will appear in a phase applied at the output. Please understand that negative and positive do not denote any type of voltage, meaning the output voltage is proportional to the difference between non-inverting and inverting voltages, which are voltage output voltage 2 minus voltage 1, which there is no feedback, no voltage capacitor between the output and input of operational amplifier is said to be open loop condition. Characteristics operational amplifier. An ideal operational amplifier file characteristics: infinite voltage gain, infinite bandwidth, infinite input resistance between bandwidth of voltage 1, voltage 2 terminals, infinite terminal is infinite. Zero output resistance, zero output remains constant no matter what the resistance applied across the output. Perfect balance for when the voltage input is equal to voltage 2, the voltage output is 0. Single-ended input operation result of the input signal connected to the one input with the other input connected to the ground. Single-end input. Or your double-ended output, double-ended output operation discussed so far with a single output with the operational amp, with the also called the operated output, opposite output, can also be called opposite outputs as shown in figure 1. Input applied with either input result with the outputs of both output terminals. These outputs always being positive opposite in polarity. Figure 3 shows the single-ended input with the input and the double-ended output is shown. Single applied with the plus input result with the 2 applied outputs opposite polarity. Figure 4 shows the same operation with single output measured. Figure 3 shows the double-ended output. Figure 4 shows the single-ended output. Common mode of operation. The same input signals are applied both input with common mode operation. Resolve the 2 inputs equally amplified since they resolve the opposite polarity signal of the output. These signals cancel, resulting in 0 to volt output. Particularly small output signals will result. Figure 5 shows a common mode of operation. Common mode rejection. Single feature the direction connection signal with the opposite of the input highly amplified, those of the common 2 inputs the only slightly amplified overall operation applied with a different signal. We're rejecting the common signal at the 2 inputs. Differential and common mode operation. One of the most important features of the differential circuit with connection provided with the opposite operational amp is the circuit ability to greatly amplify signal with the opposite of the 2 inputs, while the only slight amplifier signal in common at both inputs. An operational amp provides an output component that is due to amplification difference if the signals applied with the plus and minus input component due to signal common to the both inputs. Some application opposite input signals is much greater than the common input signal than this. For the circuit provides a common mode of rejection described with a numerical value called the common mode rejection ratio or CMRR. Differential input. When separate inputs are applied with the operational amp, result of the different signal is difference between the 2 input voltage D is equal to voltage input 1 minus voltage input 2 common input. The signal of the common signal element with the two inputs that can the different voltage sum of the two voltages common and equal to 1/2 of times voltage 1 over the voltage 2. Output voltage single amp signals since any signal applied with the operational amp, generally the both phase and out of phase components test and resulting output expressed in voltage output as well as amp a difference in gain in the amplifier over the difference in voltage and by the equation times the common plus the common mode of gain of the amplifier times the common voltage of the given in the equation. Common mode of rejection rate, having obtained the differential gain of the amplifier and the common mode of gain of the amplifier, the measurement procedure discussed above, we can now calculate the value of the common mode rejection ratio, which is identified by the following ratio. Common mode rejection ratio is minus the differential gain of the amplifier over the common mode of the gain of the amplifier. The value of the common mode rejection ratio can be expressed in logarithms. When expressed, output voltage determine the common mode rejection ratio, and then voltage output. Basic operational amplifier. The circuit shown with the provided operation constant gain multiplier and input signal voltage 1 is applied through the resistor 1 to the minus input with the output connected back to the same minus input with the resistor frequency. The plus input connected to the ground. The signal voltage 1 is essentially applied with the minus input with the resulting output opposite in phase with the input signal. Figure 6a shows the operational amp replaced by the AC equivalent circuit. If we use the ideal operational amp, the equivalent circuit with a replacing resistor amp by infinite resistance and by resistor output by zero resistance. The equivalent circuit is shown in figure 6b. Circuit is then redrawn, shown in figure 6c, with circuit analysis carried out. Figure 6 operational order constant gain modifier operational AC equivalent circuit of the ideal equivalent circuit of the redrawn equivalent circuit of the upper using superposition we can solve the voltage 1 terms components is due to each source of the voltage 1 only that the zero sources and more. Alright, then we show that voltage is output is over voltage initial over the equal the voltage negative resistant frequency over the resistance 1. Unity gain show that the voltage output over the resistance voltage 1 over equal to resistant 1 times resistant 1 plus resistant frequency over resistant 1 equals 1 plus resistant frequency over resistant 1. Practical operational circuits. Inverter amplifier. Most widely used constant gain amplifier circuit. Inverter amplifier shown the output is attained by multiplying input fixed constant gain set by input resistor feedback resistor. This output also being inverted from input, we can rewrite non-inverting amplifier. Connection figure 8 shows the open amp circuit which works with a non-inverting amplifier. Constant gain multiplier should be noted with the inverting amplifier connection is more widely because of the better frequency stability discussed later. Determine the voltage of the gain of the circuit. We can use the equivalent representation shown in figure 1416b. Note that their voltage across resistant 1 is 1 voltage 1 since voltage input is equal to 0 volt. There must be equal to the output voltage through the voltage divider resistant 1 and resistant frequency so that the summing amplifier the circuit show with the 3 input sum for summing amplifier circuit provided with the means of the algebraic summing adding 3 voltages can be applied with a constant gain factor using equivalent representation shown in figure 9. Output voltage expressed in these terms. Voltage output is the negative of resistor frequency over resistor 1 times voltage 1 plus resistant frequency over resistant 2 times voltage 2 plus resistant frequency over resistant 3 times voltage 3. In other words, each input adds voltage output multiplied separate constant gain multiplier. If more inputs are used, they add additional component to the output. And subtractor, figure 10 is the subtractor. The aim of the subtractor to provide output with equal to the difference two input signals proportional to their difference minimum offset. Either resistance 1 and 2 are parallel, and resistance 3 and 4 are parallel. Operational amp in integrator. Operational amp integrator electronic integration circuit because around the operational amp perform a mathematical operation integration with respect to the time and the output voltage proportion input voltage integrated over time. Input current is offset by the negative feedback current flowing through the capacitor, which is generated by the increased output of the voltage for the amplifier. Output voltage, therefore, depending on the voltage voltage input current is the offset by the inverse value of the feedback capacitor. The greater the capacitor value, with less output voltage has generated to produce particular feedback current level flow. Shows an ideal circuit. The circuit operates by passing current charge of the discharge of the capacitor frequency by the time of the conservation drive of the retained virtual ground condition at an input with the offsetting effect of the input current. Referring to the above diagram, the operational amplifier, assuming the ideal nodes as voltage 1, voltage 2 had equal, so that the voltage 2 is virtual ground, the input voltage passes through the voltage input with the resistor 1 through the resistor, producing compensating current flow through the series, maintaining a virtual ground. These charges discharge the capacitor over time. Because the resistor capacitor is connected with the virtual ground, the input current does not vary with the capacitor charge. The linear integration output is achieved with the circuit. It can be analyzed with the Kirchhoff current law of the node voltage 2, keeping the ideal operational amplifier behavior in mind. So right here we have a voltage input, resistor 1, negative voltage 1, voltage 2 to capacitor, and voltage 2 with a resistant inductor, and voltage output. Amperes 1 equals amperes base over the amperes frequency, or ampere base equal to 0. Ideal operational amp 1 equal to ampere F. The capacitor has voltage current relation governed with the equation ampere C with C with equal to dVc over dt. Substituting appropriate values, we get several other equations. Alright, operational amplifier differential amplifier. The basic operational amplifier differentiator circuit is exact opposite of the integrator amplifier. That it will be would look for the previous tutorial of the position capacitor resistor that had been reversed. Now with the reactance capacity is connected to the internal input terminal, inverting amplifier resistor RF. The negative feedback resistor feedback of the negative feedback element across the operational amplifier is normal. Operational amplifier circuit perform a mathematical operation differentiation that produces voltage output of a different proportional to input voltage rate of charge change with respect to the time. In other words, the faster the larger input the voltage signal, the greater the input current, greater will output voltage change, and the response becoming more spike in shape. As with the integrator circuit, we have a resistor capacitor with forming an RC network as across the operating amplifier resistance, reactance, and with the capacitor playing a major role with the performance operational amplifier differentiator, and they show the amplifier differentiator circuit. The input signal of the differentiator applied with the capacitor blocked with the DC content with no current flow with the amplifier summing the point with the X resulting zero output voltage of the capacitor is only known as an AC type. The voltage change with the pass-through of the hoop of the frequency depending on the rate of change with the input signal of the low frequency of the reaction for the capacitor with a high resistance, low gain, radio feedback capacity, and low output voltage operational amplifier. High frequency reaction with the capacitor is a much lower result of the higher gain, higher output voltage differentiator amplifier. However, high frequency operational amplifier differential circuit becomes unstable. It will start with the oscillate duly, mainly first order effect to determine the frequency response. Operational amplifier circuit called for the second order response with a high frequency given an output voltage higher than that would be expected. To avoid high frequency gain in circuit that needs to be reduced by adding small value capacitors across the feedback resistor and so we have amps input of the amp feedback, and amp feedback is equal to voltage output over the resistance feedback charge of the capacitor of the capacity voltage across the quincence is equal to current times the voltage in the input rate of charge of the quincence, the distance and time of the quincence over the therefore, our output voltage is constant with a negative resistant frequency with the current and time directive of the input voltage of the voltage input respective time minus signs of the 180 degree phase out with the input signal converting input terminal with the operational amplifier. Module 3, number system.